Hello and welcome to my video, lesson 4.5 on extra word problem solutions. So we have the assignment on Google Classroom, which had some extra word problems, and a bunch of them are from the textbook. So take a look at page 262 for questions, and the solutions are on the back of the textbook, page 548. I'm only solving the questions that weren't given. So there's two questions that are not given in the textbook and not given as solutions. So we're going to take a look at those, and hopefully it gives you a good idea of the application of this topic. All right, so let's take a look here. The sum of two squares, okay, so first of all, sum, okay, so that tells us that it is adding, and it's of two square, or the sum of the squares of two consecutive numbers is that. Algebraically determine the two numbers. So what we're going to do is say that we're adding two numbers, right? And it's going to get to this number, but we're adding the squares of two numbers to get to that number. Okay, so the sum of two consecutive numbers is that. So now we just need to get ourselves another equation, okay? And so we're going to say if they're consecutive, okay, if they're consecutive, then we can say that A is B plus 1, right? Consecutive means that it's the next number in the line. So 1, 2, 3, 4, 5, 6, whatever. So if we choose 3, then the next one, 4. Okay, if we choose 5, then the next one, 6, right? So they're consecutive numbers. So A equals B plus 1. Now that we have two different equations, we can use this B plus 1 and substitute it in for A. So what's that going to look like? Well, we're going to have B plus, or B squared plus B plus 1 squared equals 3,785. All right, and then let's expand this here, or we could simply plug it into our calculator. So there's a few different ways of solving this. We could go with complete the square. We could plug it in our calculator. We could use quadratic formula. So if we're going to do a bunch of those, we want to have it in the regular form. But if we're just plugging in our calculator, we could simply do this. And plug it in like that. And oh no, I just pressed clear. Okay, that's really annoying. X squared plus bracket x plus 1 squared, and then down we're going to go here and we're going to do the same thing, or we're going to put the answer in there. So what this is doing is we're going to find the intersection between those 2 points. So that's a very nice high number. So we're going to have, well, we're going to have some pretty big numbers here. But let's have our y value, let's make it 3,000 as our minimum and 4,000 as our maximum. And let's make the scale 500. So our x values are really where it's going to be tricky. Because we're going to need something big enough. So I'm not even sure what that's going to look like. So let's go with 200 as our maximum and negative 100 and see if this works for us. All right, so it does work for us. We have two values there that do work. We can also change our minimum if we want to, so we can see the whole thing. Okay, so you kind of just have to play around with the window settings. You might get better as you get used to it, but that's what we have here. So we can even make this smaller. There you go. Maybe easier to see. Okay, so that does it with the calculator, but it's telling us algebraically. Okay, so we know how to do it with the calculator. Now let's try to do it algebraically. So two different possibilities. The first is complete the squares, or we can factor. So let's take a look here, and let's multiply this out and see what we get. So we're going to have b, so b squared plus 2b plus 1 equals this whole value. Okay, so now we're going to simplify the left-hand side. So we have 2b squared plus 2b plus 1 equals 3785. Okay, and now we can see if we can just factor. Let's see here, 2b, and this is PSA 2 method. Oh, we're going to have to move that over. Okay, we moved that over. Now we'll divide by 2 on both sides. So we're going to have b squared plus b minus, we want half of this, so 8. There you go. So 1892 equals 0. And so now if we're still solving for b, so perhaps at this point, can we factor it? Basically, we're looking for two numbers that are really close, so we can have a negative and a positive. So what I'm going to try to do is I'm going to square root that and see if I can get a number that's close. So 1892, square root of that number. Square root of 1892. So maybe 44 or 43. So 44 times 43, is that going to give me the right answer? Yes, it does indeed. Awesome. Okay, so we want to have the bigger number as the positive and the smaller number as the negative. And so now that we have that, we can get b is equal to either negative 44 or positive 43. And a is just adding 1 to that. So negative 43 or positive 44, which makes sense that they would end up being the same, just opposite signs. All right, so the factoring here is a little bit more painful than it sometimes is, but hopefully at least the method part makes sense. So hopefully the method part makes sense, but the factoring part is a little bit complicated, or a little bit of a challenging one. Okay, we can double check our answer now by going second function calc and going intersect and enter, guess, enter, and that point is 43, and would you look at that, it's the same. So algebraically we got there, graphically we got there as well. Okay, here's another question. The height of a projectile as a function of time is given by the function. Oh, it doesn't show me the function. All right. Let me just pull up the function in that case. Okay, write an equation to determine the time when the projectile was 400 meters above the ground, and then B, determine the time to the nearest tenth of a second. So let's zoom in on that question. Here is the function. Let's see here. Will it transfer? Ooh, it does transfer. All right. So there's the function. Important that we have a function. Okay. So the height of the projectile as a function given by this. So the height is the y value. T is the time. And so over time, the height is going to change and it's going to accelerate downwards. It looks like it's starting with a positive or an up direction. Okay, but it's going to be curving down. Okay, write an equation to determine the times when the projectile is 400 meters above the ground. So we're solving for when the height is 400 meters. So like this. So we're simply changing the height to the value given. And determine the time to the nearest tenth of a second. Well, you could, I always, if I'm allowed to, I would like to use my calculator. So we're going to do that right here. So negative 4.9 x squared plus 110 x plus 2. And we're going to have a maximum of around 400, so let's go with 450. It can't go negative in time, and I'm guessing this is not going to take that much time, so let's go to 50. Okay, not bad, not bad. We can go a little bit taller than that, just so that we can see more. And we can go a little bit smaller than that, so 30. Oh, so close. We want a little bit smaller, and we can definitely go a little bit taller as well. There we are. Perfect. So, like you've seen me do, I'm just fiddling with the window functions until I can see the parts that I want to see. Okay, determine the time to the nearest tenth of a second. So basically, we're going to find the different intersects. Okay, and because there's two different intersects, it's important that you do guess. You use the guess function and make sure you're close to it. So this tells us x is 4.5, so nearest tenth of a second, right? So that's 1. And then the second one is all the way over here, which is 17.9 seconds. All right, just looking at the intersects. So we can use all sorts of different methods, whether that be completing a square, whether that be factoring, whether that be graphing. We can use all sorts of methods to solve these sorts of questions. And yeah, I hope that this video helps you understand the application of quadratics. Good luck.